In the second half of today's lesson, it's a little review on writing and solving an equation, and then we have some rational expressions that we're going to end up multiplying. So let's start with this equation that we're going to end up writing. It talks about Jim charges an initial fee of $60 and $80 per hour. So whenever you see the words per hour, each hour, this gives us a hint that we might be talking about a variable. If we go to the question, it asks us after how many hours. There's the question right there. So yes, since the question matches the per hour here, or these units are the same, hours and hours, that means that this is our variable term. And so we could start by even writing Jim's equation, and then we'll get over to Ted. So Jim had an initial charge of $60. Initial means just one time. You're not going to pay it again. And so we are going to take $60 and add it to his variable amount, 80M, or H, we'll use for the number of hours. So that's Jim's equation. Ted charges a one-time fee. Oh, that's the same thing as an initial fee of $160. So let's write that down. Ted, his charge is $160, one-time fee. Not going to pay that again. Plus $70 each hour. When you see that each or per, typically tells us it's our variable. Since the units there, after the word each or after the word per, match the question, hours, and they ask how many hours, this is our variable term. And so we go ahead and write down 70H. And so what they want to know is, when will they charge the same? Same means equal. So we're going to set these two equal to each other. So we've got 80H plus 60 equals, and then 70H plus 160. And so we just start moving terms around, doing opposite operations. Maybe subtract this 70H from both sides. And then we can also subtract this 60 from both sides. Notice that I'm bringing the constants to one side of this equal sign. Variables are going to the opposite side. So here I do that subtraction, I get 10H. Over here I end up with 100. And so I do that division of 10, dividing by 10 on both sides, and I end up with the number of hours. The hours equals 10. So 10 hours is the number of hours until they charge the same amount. So the next problem, we're going to end up wanting to write this as one big fraction and then factor. And so we've got our t2x squared, we'll start off with, and then we've got our trinomial, which we'll end up factoring. And it factors to an x, and this looks like a 5x. I'm not sure what this is supposed to be here. Let's go ahead and fix that. It looks like it's a minus x, and so I ended up having an extra part here. So let's go ahead and just erase that part that's not really needed. So fix this problem. Actually, it was supposed to be 5x. Let's go ahead and just change it to that, so we'll actually get a good answer here that we'll like. So let's go ahead and modify this. X squared minus 5x plus 6. It looks better. 4x minus 8, x to the 5th power. Alright, so now we can go back to the problem. And let's go ahead and factor this. It factors to an x minus 2 and an x minus 3. It factors to two negatives because they multiply to make a positive and they add to make negative 5, so it works. Well, let's do the same thing down here. Now, if you look at the terms, always look for common factors first. Pull those out because you'll see extra stuff that's left over that will end up factoring, possibly. Or it might have a common factor, like this one. If you take out the 4, put the 4 on the outside, you do the division, 4x divided by 4 makes x, 8 divided by 4 makes 2, and you see those x minus 2's will cancel. Let's bring down that x to the 5th, and now we can go ahead and do that canceling. So again, those x minus 2's are canceling. 2 goes into the 4 2 times, and we'll go take away 2 of these x's here, take away 2 x's from the bottom, we're left with 3 x's on the bottom. So what we've got left over is an x minus 3 all over 2x to the 3rd power. That is our answer. Well, this next one, we'll do the same thing. Let's write this as a fraction if you don't see it as a fraction. And let's go ahead and take out common factors. Well, 4x, nothing much you could take out there. But here I see 4 goes into these two terms. When I do that, I end up with an x squared minus 9. Well, this factors further, but be observant. Do we have another x squared minus 9? We sure do, down below. You could factor that, but if you already see it's the same, let's just go ahead and leave it and then cancel it out. Those will cancel, leaving us just with 4x times by 4 makes 16x. Always good to look at the whole problem as a whole as you're going to see what can cancel out. I like going ahead and using the commutative property with this type of problem. When there's no addition signs, no subtraction signs like there were on these last two, you can do this. I take all the x's and combine them. 7 and 9 make 16. W to the 4th. And then do the same thing down below. Look at the numbers that are going to reduce, though. I'm going to put the 3 underneath the 15 because that's going to reduce. 8 goes underneath the 12 because that will reduce. And then count up the number of x's. It looks like we've got 8 altogether. And then w's, it looks like there's 5. And then just cancel out those common factors. So I see that 12 can go into 8. Well, let's see here. 4, we can divide them both by 4. That's what we'll do. And so this will become a 3 is what that becomes. This becomes a 2. And these 3's will then cancel. So what's left over is a 15 and a 2. Well, we can start there. I'm sure we'll have some variables also, but let's continue. Looks like the x's are canceling out on the bottom. And there's more x's on top, leaving us with 8 x's on top. So 15x to the 8th so far, but we're not done yet. Got to go over the w's. These 4 w's are going to take away 4 w's on the bottom, leaving us just with 1 w left on the bottom of the fraction. So just w or w to the 1st. That is our answer. So those are types of problems that you'll see on tonight's homework. Good luck.